Okay, so this is the box. It's working. Honestly, it's not really working. I mean, it lights up and everything, but I think it's too bright. So I have a bunch of to-do list things, but I'm really not going to be able to do all these because I have homework. But basically, I want to test pulse width modulating the MOSFET on the PCB so that I can maybe dim it down. I also want to go grab a test sample of something that I know is vaguely glowing. I think that this yellow Tiffin filter that I have on here is not aggressive enough, unfortunately. Um, so that's too bad. I think we might see the green, but the blue really comes through. So that's not the best. We'll try to figure out something for that. Ideally, I go to Home Depot and I get some small, like not M4, but number 4 screws or something. I'm gonna grab a hinge because the problem is the way that this door works is it doesn't go as far as I would like. But basically, the plan is to use some magnets and a small 3D print to hold it up, and then okay, and then the main thing though is to get this breadboard into something that's just mounted on it, because cables, I hate cables, but we gotta figure out something. And so I was thinking maybe something like this, like we just mount it to this. But then I'm thinking, actually, what I want to do is I want to go to Micro Center, buy another Pico that doesn't have the headers soldered onto it. Um, because then I can just wire directly onto it and it'll just live here. And so we're going to try to figure out the CAD for that. Okay, so I might actually. Unfortunately, I actually, this morning, I kind of prematurely, I sprayed arabinos on here. The liquid is pooling, which is not great. But I sprayed 0.5% arabinos onto this P-Glow. Um, okay. So maybe I just need to go get parts right now. Maybe. And then I want to go get a petri dish that I know is like at least vaguely glowing to test if we can see any fluorescence at all. I'm thinking I might do also another test where I like use just a piece of like orange plastic, because that's what we use for the box at BioCurious. But so I think the general stack up is going to be, there's going to be a base thing, a base plate, kind of like this. Okay, that has, and maybe it has lobes. Maybe it's lobed. And this has a bolt that goes into the wood. Getting all this working properly is going to be really sick and twisted. But then on top of that are going to be some four little standoffs, I guess. And then the picot will go on top of this little plate that connects to the wood. So we have wood to picot is a plate. And then the picot to and this is going to be interesting because this is going to hold the screen and the buttons. So this is the screen and buttons. Okay, so I wonder if we should CAD out a little test. For the buttons. This is going to be a tricky thing. Oh, so I downloaded the Pico CAD model. Bro, I have homework, man. I don't want to do my homework. I want to do this. I want to cable manage something properly for once in my life. One thing that I want to do as well is oh, did we already do this? Wait, no we didn't. This is gonna be lens max. Oh, wait. Lens. Hole max diameter over 2. Alright, that's already an improvement. So that should even out at least some of this nonsense. But because right now it's like off center, but I'm not gonna reprint this just because this was like an $8 print and I feel bad about wasting all that plastic. So alright, so let's do the import. Where did it go? Parts. I guess I needed to do it into an assembly. That's pretty nice looking. Oh no. Dude, how do I undo this? Come on, man. Can I undo the import? Ugh. It's like, why is this an assembly, bro? I think that's wrong. I think it's making that up. Ugh, that didn't work. AI advisor? That's pretty cool, actually. I don't see the clock. Where's the clock? Ooh. So how do I roll back to there? Return to main. But how do I roll back? I wanna like... Can I delete this? Branch to create workspace. How do I just delete these changes? I just don't want these changes. Restoring changes into B1 from V1. Okay. Wow, I've never done a CAD merge conflict before. I think I just did it though. I think we're good. But wait, how do I call this main now? Okay, I think we're good. So now, right click on a rotor form. Oh, okay. All right, so that's how you do a merge conflict in OnShape. So we want to do import this thing, combine into a single part studio. Let's see what happens here. We know how to fix it, so it's fine. But it should just be one part studio at that point. And then if anything, we can just make a assembly. And then fix everything to itself. Why is it so dark? Oh my god, it's got so much. It's got 300 parts in it. Why is it just all black? Was the other one all black? Okay, it doesn't matter. The thing that matters is that we can click on this circle and we can click on this circle. Okay, so let's get a new part studio in here. So this is going to be the so this should be 2 parts. I think the first thing I want to do though is figure out how we are going to model. Basically, okay, so I think there's a lot of chores and driving that I need to go do. So we need to get smaller screws, and then we can at least get the magnet thing working, and that'll be nice. Because I don't like that this thing these things collide so close to each other. I'm limiting my travel, and I hate that. But then here, the problem with this is I wonder actually. Okay, so let's try to actually do this. Okay, so we got our calipers. The most useful tool out of any tool to own, I swear it's calipers. Okay, so this is 6. So right off the bat, 3.5. Okay, and then .5 again. And then this height can be kind of anything. This one looks like it's like 2.5. Okay, so that's the button. But then here, what I'm wondering is, these legs are curved outward. So what I'm wondering is if we put a sled underneath it, like a 1 millimeter sled. So let me think about this. So it would go like this. It would go gap, thing, gap, small thing. Okay, so let's just say that this is like 30 long. I don't know if even that's right. But and then this is gonna be like 10 long. 10 long, 10 long. Alright, so we're gonna extrude this. Actually, wait, hold on. Let me continue the sketch. So what we want is like a small, like 1 millimeter rectangle here. So this thing we want it to be 1. And then that thing, I thought it isn't that. So here, let's just make this like 2. I mean, right now I'm just trying to get a very rough idea of like. So wait, so that won't work. What we need to do instead is we're gonna need a G. Here, this is gonna be 1. This is gonna be 1. And really, we could make it 2 if we want. This is gonna be 1. And then this can be 1 or 2. Let's make it 2. Okay, and then so then we want, let's see, but the space between these contacts. Oh, here, I have an idea. At its most widest, the prongs are like 8. I should get my iPad for this. Because, yeah, we want it to go. Actually, hold on, let me think about this. I always forget this. The way these buttons work is that when I click this button, the left and the right sides are connected together. So yeah, we want them up and down, not left and right. So let me change this around. Actually, one thing that we could do in that case is I wonder, could we not just do this and this? So we can shove it in there. So this is just going to be like, so that's a 1. This is a 1. This is, let's make it 2. Actually, wait, let's make this whole thing like 15. But we only want to hold one of them. So this we can make it 10 then. Or actually, wait, we're going to delete this and just make it 2. I'm just trying to make a scaffold that I can like. So we want this to be 1. And then actually, I want to delete this and just mirror it. Okay. Actually, let's make this like 25. So that then we could maybe put 2 of them in here. The issue now is that we actually want to make a little break. So for instance, like break like this. Let's make this like 3. And then here to here, we want this to be 6.1. And then we want another one like this. Let's make this 3 or something. And then we want this to be 6.1. So then, and then, so instead of that, let's see, is that what's defining this length? We just want this to be coincident with that. Okay, and then this, we delete this and we make this 2. Okay. So now we have room for 2 switches here. And we want to delete this. And we want to mirror again. But wait, actually, mirroring is not what we want to do. Because what we want to do here is instead of saying that this is vertically constrained by 1, we basically would need to say that that's where the prongs go, right? So we want 3 millimeters. Oh, okay, that's perfect. All right. So now I want to extrude these by like 2 millimeters. So that seems pretty good. I'm going to actually print this. Except in here, I'm going to delete. Actually, wait, if I delete this, nah, it's fine. Cancel. All right, so we're going to export this. Okay. So we should be able to put 2 buttons in there, solder all of the grounds together on the bottom, solder that ground to an actual ground pin, and then solder each of these to its own GPIO pin. Okay, so okay, so the next thing is basically figuring out I want to actually draw another line. Right there too, because you kind of need to be above that. Okay, so then for a Pico standoff thing, this is what I'm thinking. So like a Pico standoff thing. So on here, we basically why is it so black? Can I change the appearance of everything? Much better. Okay. Oh, it's good that that exists, because that was crazy. Okay, so this is 51. By 21. So 51 by 21. And this is the Pico 2. We're actually going to be upgrading the Pico 2 because I don't think I'll be able to get a Pico. These are actually really nice. I like these. All right, so geez, this thing is crazy. Okay. Okay, so let's build this standoff thing. Actually, wait, we have the mechanical drawing here. So I don't know why I didn't just use that. So from the center to the edge is 4.8. And from, I guess this is the tangent point here. So it's, so to just sort of copy that over. Pico standoff. If we just draw a sketch, rectangle 21. Oh wait, this is 51, 21. Like that. And then we do a circle here. This circle is, I think, 2.1. So, is this the Pico 2? This is the Pico, so wait, hold on. Pico 2 data sheet. Mechanical. So here we go. Alright, so it's also 2.1. I don't know what drawing program they're using for this, but this thing is goofy as hell. Look at these big eye arrows. Look at these big eye arrows, bro. What the hell is that? So this is 2.1. Okay, then what did we say that from here to there that's 2. So from here to here is 2. But the copper pads are significantly bigger, I guess. That's fine. I don't really care about that. And then this to here is like 4. What did they say? 4.8 it looks like. That's pretty big. Okay. And now we can just mirror. I really wish they had a double mirror. I feel like it would be a really easy feature script thing, but feature script kind of sucks. Like I do this 100 times a day if I'm CADing. I'm constantly doing a double mirror. Okay, so what I'm thinking is that we basically draw it like this. So let's keep editing this sketch. Basically I want an arc from like from here to there. Like that. Actually, is that gonna work? We don't want that because we want it slightly standoff. So wait, hold on. First we want like a line like this. And a line like this. Then these are vertical. Or actually, I don't know what's better, vertical or equal. I don't know. But then we want an arc from here to here. And we want it like that. Yeah. So a little tab. And then what's not defined yet? Okay, this distance. I say we just make it 5, right? And then we put the thing like this. And then we mirror this. Select the mirror line. Looks good to me. Oh wait, but you know what? We don't want to do this quite yet because we want to draw the circle. So here, now this is an interesting question because basically I need to go get a part and see if I can do this. Okay, so it looks like the smallest that I have is an M4 by 8. And that's plenty for me. So basically what we're going to do is we're going to drill let's see, I guess these are the M4 by 8s. Is there something even smaller? That's an M4 by 10. Anyways, an M4 by 10 is exactly what I want. So we're going to do an M4 by 10 wood threaded insert, which has 5.5. So we're going to drill a 5.5 hole in the wood at some location. So this thing is going to need to be for an M4. So let's just make this 4.2. Now we can mirror this. Okay, great. So now we should be able to extrude. So I don't even know why I put these holes here, because we want these holes for right now, but we're gonna use them. That's the main thing, is we're gonna use them. So here we can make this just like 3 millimeters. We really don't need this to be extremely strong in any sense. But here I want to see this, and then I want to sketch on here, and then, oh, but you know what? We kind of want to make this plate slightly bigger, because the way this is going to work is we're going to put an M2 self-tapping screw in here. And the idea is that we want some clearance. So what if instead, let's see, is this going to mess me all up? This is going to mess me up because they're all from the edges. Because here, let me sketch out what I'm trying to do and then we'll fix it. So what I'm trying to do is basically sketch on here like, yeah, let's say 4, and this one we want it to be like 1.7 maybe. We should do some standoff tests actually. Why don't I generate... This is what I feel like Zoo would be perfect for. Does Zoo have a built-in AI? I feel like Zoo would be perfect for doing these kind of tests. Okay, so okay, fine. Let's just do it instead of babying around this thing. I feel like I've probably already done this experiment before, but actually, you know what? Let's just ask this. If I'm using a self-tapping M2 screw, what's the correct into PLA? What's the what should the hole size be that I screw into? People have already figured this stuff out. Why would I print out this crap? Okay, there we go, 1.6. So we're gonna make this thing 1.6. Okay, and so the idea then would be, actually this will work totally fine. Wait, but what is the deal here? I thought I'm hiding that thing. Alright, so then we extrude this like, I don't know. Wait. What? Like 10? You see these on a lot of injection molded parts. Usually I think they have a draft angle though. But I should be able to just feature mirror this. Actually, I wonder, does circular pattern work how I expect it to? Alright, so let's try this. I don't do circular pattern a lot. So the part pattern, feature pattern, this extrusion, axis of pattern, yeah, because it's like ellipsoidal or something. That's not how this works. You have to do mirrors. But why would I do mirrors when I could do mirrors in the sketch? That's kind of my philosophy. But it's so annoying. It's like, ugh, dude, they changed something. I swear they changed something about the way that this search tool thing works. It used to remember the mirror and I could like hella fast do it, but now I can't. Okay, I don't care if this gets duplicated, honestly. So now, this extrusion, we just need to add in this thing, this thing, this thing, this thing. And I don't know why it's showing, this is supposed to be hidden. Okay, it doesn't matter. 10 is a little high. Even that's pretty high. I don't know why we would need to do it this high. And then, metric, bolt dimensions. Ugh, no. Wait, engineer's edge. This is the one that I like. Wait, is this the one that I like? Yeah, I like this one. So this is for socket cap. Wait. No, this is the one that I don't like. I don't like this one. Because this doesn't have the stuff that I want. Metric, socket, cap, dimensions. Maybe it's this. Oh, here we go. This is the one that I like. So it is engineer's edge though. So basically what I'm trying to figure out is A. So the head diameter of an M4 is a 7. So if I draw a 7 around, okay, so we have plenty of clearance for the head, which is good. Okay, that part is probably finished. The main question here is that's not correct. Actually, you know what we could do? Why don't we just... Let's see. Which way is this screen gonna go? Where's the screen? This screen is gonna go like this. It could just be sticking out above as long as it's goes into the plate, because we're gonna tap into the 4 holes. So we need to actually CAD this out. But it's already 1 p.m. Let me go get that part and just look at the buttons and see how that's gonna work out, because this part is gonna need to expand into a whole thing up here, because I'm thinking that that's how we're gonna want to do this. Is we're gonna want to basically have like the buttons. Maybe we could have like the screen here and the buttons here. But I think 2 M4 bolts is plenty to hold this. This thing's not going to undergo any forces, so it's not really an issue of that. It's more of an aesthetics thing, I feel like. Um, okay, I feel like this is starting to come into picture for me. I sort of started out the day feeling like I have no idea how to do any CAD whatsoever, and now I feel like this actually could work. We just need to change this base sketch to include the other parts of this whole thing. So basically we're going to have 2 bolts that hold in everything, and then the buttons will be interesting because the buttons need height, but they don't have any way to do standoffs. Wait, can we look at the button thing? The button holder? I think I have an idea. Let me go get the thing. What did I make this? I made this 2 millimeters thick. That might be enough. I might go 1.5. So all right. So let's figure this out then. We basically just want to okay, so wait, let's start with the screen. Okay, so $35.4. All right, we're gonna do 35.4. So this way is 35.4. And this way is 57.4. 57.5. Okay. Then, actually, you know what? Can I try? I'm gonna try to find and see if we can get a drawing, because it's always nice when they sell you something and you get a drawing. So let me just look up LCD wave share. Oh, nice. They give you a really nice drawing. Okay, so this is actually supposed to be exactly 35. So let's just do what they say. This is supposed to be 58. You know, you rarely get drawings, which is really cool. The center of the holes. The thing is, I measured the holes to be really small. I tested in a 1.7 millimeter thing will go through it. That's why gauge pins are so nice. Anyways, let's draw a circle here. So supposedly this is 2.5, 2.5, and then I'm gonna say that this is 2. And then we can just do our double mirror thing, which is painful as all hell. See, and then invoking mirror again cancels it. I just don't understand. It's like Onshape could be good, but they decide that they don't want it to be. And then okay, and then this actually has a an arc like this, I guess. I don't know how you do this arc. It's like I want to chamfer this thing. So the radius on it is 1.5. But then, can I say this and this are tangent? And this are tangent? Well, that'll probably... Okay, no, that's perfect. Sometimes I just like to get a little fancy with it. Get a little fucking fancy with it. And get a little fucking fancy with it. Alright. Good. What is this? Oh, that's the radius thing. Okay. Okay, great. So now we should be able to extrude this thing. Um, 1.6. That's the standard PCB. They didn't give me that dimension, but it's like 1.6. Okay, so this is the PCB. But now the actual screen dimensions are like 35 by... Let's see, are we zeroed? I'm not going to be super precise about this. I just want to get like in the ballpark. .7. All right, I'm gonna just we're gonna sketch on here. We're gonna draw a rectangle like this to here. This is gonna be 50. We're just gonna say 50. And then what I want to do is draw a line from... Why am I not... Oh, because I don't have the U's. So I want to get a line from here to here. Okay, now in this segment, No, yeah, this and this. Wait, I don't think I'm allowed to do that. I have to go and fucking find the... If I do a point here. Okay, yeah, this and this, Shift M. There we go. God, is that painful. Okay. Fucking locked in today, brother. Alright, 2.5. This doesn't quite seem right. I'm gonna change this to be 48.75. That looks a little bit more accurate. Okay. Yeah, because it's probably... Oh, it's even closer to 48. But that should be sufficient. And then here, actually, I wonder how we're going to do this, because I kind of wanted to learn the on shape. I wonder if I can get metric pin gauges. Texalan. Dude, pin gauges are expensive, dude. I'm not buying pin gauges. But what is the standard? I mean, it's a standard 2.5 millimeter pitch hole. Because there's no way I'm going to be able to get my fucking thing in there. I think it is 0.5 millimeters. Okay, let's just say that they're 0.5. We don't need to get that crazy with it. But what I want to do is I want to sketch on here a circle that's 0.5. Ooh, that's awfully small. But yeah, that's probably right. And then I want to linear pattern it. Other way. How do I change the direction? Fuck. And then we want this to go 8 times. And with the spacing to be 2.54. Okay. That's kind of good, except for, yeah, this needs to be vertical. There we go. And then what we want to do is we want to draw a line between here and here that's construction. Then we want to shift S a midpoint. That's the midpoint. 1, 2, 3, 4. Okay, that's the midpoint. So then we want to draw another. Let's do this. And then I guess we make another construction line. Let's see, I should be able to drag these off of center. And then I should be able to shift S. Actually, I should be able to just go like this, like that. Okay, and now I can just click on. And I know that there's a better way to do this. I know it, but I don't know what it is. I would assume that there would be something like select all identical copies of it, but I don't know. It's probably not 0.5. That seems too small. Log 92. That's super funny. Okay, yeah, it is. That's about right, actually. Okay, good. So now the only kind of thing left is they've put this JST connector on here. And what I'm going to do, I think, is just I'm going to measure the depth to here. 4.5. So this is going to be on the other side. So here we basically just need to draw, and then the full depth of this thing is going to be 7.5. So we're going to draw a rectangle like this. From here to here, what did we say was 4.5? This is 7.5. And then this is 20. Okay, and then the depth of this is, I think that's wrong. Maybe it's right. 6. We're just trying to get the rough thing for your interference check. So this is the JST connector that we don't really care about, because we're gonna hardwire all this stuff in. And this is the pixel 00s right here. Okay. Okay, so now that we have the screen catted out, we basically want to figure out where we want to place this thing. So we know this pattern, right? 53. So yeah, I'm thinking like we should literally just draw a rectangle from this midpoint to here, and it should be the exact same footprint. So it should be, you know, I haven't been using variables at all because I've been a naughty boy just trying to get stuff done. But what was the, wait, I have it on my phone. I got distracted. We can just click on this. Oh wait, we can't click on this edge. We gotta click on two faces because I did this stupid corner rounding for no reason. 58 by 35. That's right. Okay, so this is gonna be 35. This is gonna be, yes, that's what I wanted. 58. And then what we're gonna do is draw our circles here, and we're gonna draw a circle here. We'll figure out that later, but this is gonna be 2.5. Oops. This is gonna be 2.5. Wait, that's the same one. I'm dumb. This is 2.5. And the idea is that this is gonna hold a 1.7. So let's make it 1.3. So this is gonna be a 1.3, and then we're gonna make this outer one maybe like, it's not a Q. Let's make it like, what did we make the other one? I think we made the other one like 5, right? Let's see. Let's look at this sketch. 4. We made it 4. Wow, is that tangent by coincidence? That's crazy. I'm down to just make it 4. I don't really have a problem with that. Oh wait, this is not what I want. I want this. Okay, so now... Oh, but you know what? This is... I'm doing this at the wrong time. Because what we are supposed to... Hold on. I messed this up. Let's delete all of this. Then in this extrusion, I want to extrude this too. And we're just going to piece by piece add this and make this a very wonky looking device. But it really doesn't matter. And so, and in this way we actually solve a big problem of how the wires are going to go. Because these wires, if we just make them look nice, then they'll look nice. It's as simple as that. So, sketch on here. Oh wait, actually, why don't we do this? Because we have the same extrusion. Alright, so circle, circle, 2.5, 2.5, 4, and what? Come on. And this is going to be 1.3 because we're going to put a 1.7 millimeter self-tap in there. Now we can mirror across. Okay, so now we have to do a construction line here to here and a construction line here to here. Okay, so now we can mirror this. And we can mirror this again. And just get all of it. Great. Now for this extrude, we should be able to visualize this and get that. Fantastic. I'm wondering actually if these are gonna clash. If maybe we should add a small amount of clearance. So why don't we do this? Let's make this 36. Or let's make it 37. But then we're gonna have to change a whole bunch of stuff because here these holes are now too far spaced apart. So what we're gonna have to do is go into this sketch, delete these circles, and then we're gonna have to go to this tab and find out what this is. 30. Okay, so then all we have to do is we have to copy these guys. Okay. We're gonna move. Come on, dude. I'm gonna move them so that this point and this point are vertical. This point and this point are horizontal. This point and this point are vertical. The distance between here and here is 30. And then, is that it? What's still not constrained? Something is off. Is it the dimension of this? I don't think so. Oh, it is. Interesting. Okay. Weird. Oh, because... Oh, that's weird. Alright, that's fine. I don't really care about that. So now we just need to go in here, select this and this. So now we have like a tiny bit of room. Oh shit, I think I messed something up, yeah. Just in case these things happen to be a little bit bigger than they might be. Okay, and now all we have to do is add the part for the buttons, which should be pretty fun. Oh, we're so close. This is going to be so fun to get right. Mm. Bruh. Okay, so all we need now is a little rectangle here. So we just need to go back to this sketch. Draw a rectangle like this. And this will just be the place for 4 buttons. Now the interesting thing about this part is I wonder if I want to index in a little bit of a different way, because where's my little part here? I don't like just how little I have to work with. Oops. I don't like how little I have to work with here. Yeah, I'd prefer if I could index in a way where I could avoid having to solder to this tiny little thing. Because this is not going to give me the kind of mechanical strength that I would like. What if I just do something really simple and dumb? Like, what if I just do... So, okay, wait. Let me do some calculations, right? Like, if we have 4 buttons... I should have gotten a touchscreen, dude. Touchscreen would have been cool. Honestly, no. Touchscreen wouldn't be that cool. I just need some buttons. I'm just wondering, like, if in the future I want to add more buttons. I'm wondering. Okay, wait. Let me just let's just sculpt some she out. So if I do this, and then I just start another sketch here, and then I just draw a rectangle like this. Let's see, what does this need to be? This needs to be the... It needs to just be 6. So if I just... if I just take this and extrude this by... Oh, actually, maybe that's the way to do it. But then I have no place for the cables. I was thinking, like, what if I... Maybe they don't have to be that evenly spaced. I don't think that that's that big of a deal. But so if we extrude this by 6, for instance... Wait, is 6 the right amount? Seven. It needs to be by 7, so let's do 8. Okay, why didn't it extrude? Lol. Okay, so if we just put the 4 buttons on a rack here, then we can actually put the signal pins down to these pins. We can put these pins to these pins. So let's do some math. So we need 4 button pins. Should I add more buttons just for future proofing this thing? It's a very vague question. I'm not expecting very much, but you know, it's like how many buttons do I really need? Like 2 was not enough. Bro, rotary encoders are so sick. See, that's pretty cool. 5-way nav switch. That would be pretty badass. Let's see, what do I have right now? I have up, down, um, next, and start. Oh, interesting. Okay, so I think 4 is I think 4 is actually a good number. So basically the question here is first, I think. So we're gonna have one wire going ground here. We're gonna have 4 wires going to pins here. So the question is basically in this sketch, do we want to also have? Why is this green? Because of this. Do we want to also have? Oh wait, okay, wait. So we have 4 button pins. So 4 GPIO. Then how many GPIO does the screen take? The screen also needs a ground. We could tie the ground and the screen right here. 1, 2, 3, 4, 5, 6 pins. Seems like I need 6 pins of data. So okay, so the screen is 6. Then we need 2 for the FET. I'll just say PCB. This is 2. Is there anything else I can think of? We need the 3v3 out or whatever for the screen. We need the VSys and ground for the. Yeah, so. But the thing is, we have plenty of ground pins, so that's not actually that much of an issue. And I think that's it. So in total, we need 12 GPIO. We need VSys, 3v3 out, and 2 ground. Okay, nice. Let me just check what my homework is due. Yeah, it's due tomorrow. Okay. So now the question here is, do we add basically little 1 millimeter tabs? I'm kind of inclined to do this. I feel like this is actually a good idea. So basically this is gonna be like 1 millimeter, but 1 millimeter, a little tab here, and we are just gonna linear pattern this thing. Okay, we're just gonna linear pattern this thing so that they happen. First, let's draw a little line like this, mirror this. Did I really do that, bro? Come on. That sucks. Okay. Mirror. Select the mirror line. Oh, wait. See, why? I don't understand. If I'm in the sketch, why can't I get the... Can't I adjust this thing? Customize. Let's see if we can do this. I don't think it updated. I saved it, and of course, it's not fucking working. Okay, now we want a linear pattern. I'm gonna pattern this, 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 and this. Okay, and now we want it to go the other way. And we want the spacing to be, let's see, but this is from the start to the end, so we want it to be 7. And of course it went the wrong way. -7. Okay, and then we want, how many of them? We want, let's do 5. Let's do 5. Because that should give us, so then now here in the extrusion, we want all of these little guys. I like this solution. So now here, let's just see. So wait, the inner distance should be 6, right? Perfect. So actually, can we make this 7.1? Okay, and then from here to here is 29.4. So let's just make this like 30. And this only needs to be like 15, I think, right? What's wrong with this sketch? Oh, I did something wrong for sure. Oh, but you know what? Okay, wait, hold on. This needs to be like 40. One, 2, 3, 4, 5. Okay, let's make it 45. So distance from here to here. Wait, didn't I just change it to 6? Oh, I see. Okay, from here to here. Okay, so we want it to be 41.5. Beautiful. Should we print this dang thing out? See if it works? I'm gonna print this thing out. This thing is freaking cool. So I want to add make connectors in the center points to add the buttons. And then we'll actually want to edit the button to have the prongs so that we can call those pins somehow. I don't know. I just want to learn the I want to learn the cable management in Onshape really bad. I feel like that sounds really tedious and also super fun. Okay, so we kind of have a prototype thing here. So wait, the grounds will go here, and so ground to ground to ground to ground to ground to some ground pin right here. Then the GPIO pins right here will go boop, doop, 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 doop. And then these pins, maybe we should give this thing more space. All right, so I'm actually gonna say this is going to be 7.1 times let's just add 5 more. So this is gonna be 46. Okay. And then instead of this sketch 3, this is 10. So then we have plenty of space for these cables to come and wrap around here and go into here as they need to be. And then for the V-sys, the V-sys will come under. The V-sys will come under. So that's what we'll do there. What a weird looking part. Okay. Export. Prepare, delete, insert, electronics. So this is enough room for 1, 2, 3, 4, 5 buttons. So we'll use all 5 buttons. Just I don't know what the last button is. Wait, I think that's black. Hold on. For some reason, this syncing hasn't been doing very well. Synchronize overwriting. Okay, I guess it's this. It says it's gray, but I think it's black. Okay, so the third is not ABS, I don't think. Wait. Let me go take a picture. Okay, it is definitely number 3. I don't know why it's syncing wrong. It's just wrong, dude. What? I don't know. Should be fine. Okay. All right, so there's a lot to do. I am out of here. I'm going to go do some... I got to get some new screws for the box because I hate these screws. So, okay, wait. So let me go get... All right, so I'm going to bring my backpack. I need to grab a hinge. Okay, so let me just get a to-do list. So let me go get a hinge in my backpack. Okay. All right. So let's end this thing. We did some CAD. We're going to be back, and we're going to CAD up the magnet thing. So we're going to put some magnets in this thing. For the hinge. Oh, I didn't even get a hinge. Okay. Okay. I'm going to leave a lot of this out here. I'm just going to put in my computer and my... Okay, all right, that's it.